Hello, everyone. Thank you for attending today's webinar titled Maximizing Production Painting Through Racking, brought to you by Products Finishing and presented by Therma-Tron-X. I'm your moderator, Scott Francis, editor of Products Finishing. Today's presentation will last approximately 45 minutes, followed by a question and answer section. If you have a question, you can type it at any time during the webinar in the Q&A section of the chat. The webinar is being recorded and when complete will be made available to you via email from Products Finishing. Our presenter today is Ted Duda, Senior Sales Engineer for Therma-Tron-X. Ted's been with Therma-Tron-X in Sturgeon Bay, Wisconsin since 1994 as a sales and engineer specializing in the design and sale of material handling and all types of metal finishing systems. He holds a degree in mechanical engineering from the Illinois Institute of Technology in Chicago and has 45 experience in the finishing industry, having previously worked for 3 major manufacturers of finishing for automotive, agricultural, and the general sectors. Ted,
thank you, Scott.
hand it over to you.
Thank you, Scott. Thank you, gentlemen and ladies, for joining us today. Basically, as Scott mentioned, it'll be a discussion regarding points of minimizing the production painting through racking. A lot of you probably have experienced this. Some of you who are currently painting, as well as just getting into it. Racking is probably one of the most vital points in the finishing market. It'll make and break you to the point where the cost could be exorbitant or a win. Today's discussion points, I'd like to go through some general ideas on paint finishing and some of the manufacturing points. Those of you who are captive shops are extremely vulnerable to some of the things that you see in paint finishing and metal finishing. Some of you that are custom coaters probably see a variety of it. And so basically, I'd like to go through some discussion points, some general elements of the paint system design. One of the things that we are going to discuss is manufacturing and finishing goals and environmental goals. These are key elements in any type of paint finishing in any operation. Establishing paint production needs. Again, if you're a captive shop and want to paint your own products, fine, or a custom coater, these all pertain to the type of systems that you have to look at in terms of evaluation of how you to handle the products, what your initial and future paint production needs will be, developing and implementing the paint procedures, production process objectives. Those are all key elements to making a successful paint finishing operation with integrating the systems both from fabrication through painting through assembly. We're also going to talk, obviously, part rack development, how we should look at doing product rack studies, racking for material handling types, whether it's a batch type indexing operation or a continuous. Discussion about rack loading terminology, density, and part racking for E-coat, spray liquid, and powder systems. We're also going to be discussing 2-coat system rack considerations, whether it be separate 2-coat paint line systems, integrated 2-coat paint systems, types of conveyor rack loading and unloading considerations. Conventional conveyor paint systems with typically types of material handling, paint line loading and unloading characteristics, and remote paint line loading and unloading. Some of the savings can be seen with minimizing double handling. And then part rack design features, rack fabrication considerations, minimizing rack stripping, and rack maintenance tips. Elements of the paint finishing design is manufacturing goals. You first have to establish your manufacturing goals as to what products you're going to be manufacturing or coating. finishing goals, you have to establish those, and environmental goals. It all is related throughout the whole entire plant. When you plan on a paint finishing operation, these are probably elements that some of you already know. However, I'm going to repeat those because it's vital to understanding the impact of once you establish a paint line or once you establish a procedure for manufacturing, finishing, or environmental. Your impact is going to last for years. In manufacturing goals, you have to look at it from the standpoint of establishing repeatable fabricating techniques. These are fabricating areas where you have, for those who manufacture, look at the techniques that you're using so that they can be repeated and keep the surface impediments down, minimizing them so that the finishing operation can be established so that you can keep the rejection rates down. Integrate the manufacturing process through plant, minimize double handling. It's vital from a cost standpoint, of minimizing double handling. Handle it once and handle it the second time through unloading or assembly. Reduce or eliminate unfinished and finished part storage. Many times I see a lot of these companies now, a lot of the plants that I go into still have areas where they store parts for painting, staging areas for assembly. Most of the new products, paint plant manufacturing facilities today are going more flow through and just in time. But with the onslaught of, especially today with the logistics, many are starting to do the same techniques they did back in the 60s, where they would store and use Q parts for painting as well as storage for assembly. Develop the standards for testing the products. I mean, these are all, if your company has not established that, if your OEMs or tier 1 and tier 2 suppliers, you're always dealing with the OEM requirements for performance requirements. However, with some of the other product lines that are general industrial or agricultural, these are important to develop the standards that you need for paint finishing in terms of methods. What I mean by that is the methods of how the procedures are written up for people who can understand whether or not you have new employees or old employees. They can establish those procedures on how to handle parts, because most of the problems you have out there are communication problems with a lot of people who are employed. And sometimes the turnover rate in a lot of plants are high. So if you establish those and understand it through videos or whatever, written, however you decide to communicate to the employees, those are important factors in making people understand, even simple loaders, to understand what the whole process of painting is. Get them involved into the process. Have them take ownership. That's part of the other aspect of developing standards and testing. Consider part design for painting. Those are aspects that I'm going to get into here, and review and monitor the assembly techniques that you're doing so that you're not damaging product. It's relatively easy to assemble or package, and therefore being able to minimize any defects or rejects during the handling process. The finishing goals. One of the things that we have to look at, and everybody should know this, but some people that may be new or not familiar with the requirements, identify the technologies that you need to have for your materials substrates, whether it's steel or aluminum. If it's steel or copper or whatever it may be, the process for pretreatment and surface treatment prior to painting is the key vital importance for paint performance. It's the bonding agents that help facilitate the paint adhesion, paint performance, durability, etc. You might consider iron phosphate, zinc, zirconium, zinc phosphate. A lot of new ones that are out there are neutral pickling to etch to weld areas, and etc. In aluminum alloys, it could be all kinds: zirconium, clean only, aluminum, iodine, uh, conversion coating, or non-chromate. And the types of paint finishes that you want to consider are prime coats, whether it's a single prime coat or a single finish top coat for general industrial interior use or exterior use, like the outdoor garden market. There's a lot of people that are looking at a single coat finish. Two coat finishes like prime and top coat, and tri-coat finishes where you have a three coat process is used for long-term durability, such as these paint transformers that are out there in the field for electric power. That's a big thing right now because the durability of a coating to last 20 years has to meet a lot of criteria and a lot of environmental issues. Environmental aspects. When we look at a paint finishing system, we look at all three different categories: manufacturing, finishing, and environmental effects. The choice of the type of paint or the surface treatment that you have, those are the key elements of integrating a successful paint finishing operation. Choosing HAPS-free and low VOC materials for paint is one of the utmost. And 20 years ago, it wasn't a real major factor. It became that way now, and now everybody has to look at it. There are some applications where you're not able to because of the finish type requirements. A lot of water-based materials are being used today for the automotive market. There's still a lot of progress to be made in that area because of performance requirements. Consider alternative process to reduce the environmental effects of air and water is what we're looking at here, like water and powder coating. When you start to try to consider a powder coating a car body, which has been done, there's a lot of issues that come along with that and a lot of cost that's involved in that. We're not there yet, but they're going. That's why a lot of the OEMs are going to water-based finishes. One of the things that most and a lot of the purchasing people like to buy materials that are really cost effective in terms of economically, but sometimes you have a lot of concerns with controlling that material entered into your plant. You can be getting the substrate materials, whether it's carbon steel, stainless, or whatever, galvanized. The types of material that you process through the pre-treatment, surface treatment prior to painting are all etched off into the waste streams of water when you're doing an aqueous type cleaning system. And those are pediments that come into the waste stream. So you have to be able to control what those materials are and identify them, at least know what those products are so that you know what you're contending with. We have customers that have all kinds of issues with phenols and arsenic and copper, but they're using carbon steel parts. Well, a lot of those are used for lubricants and cleaning chemicals, and depending on what you look at all the material safety data sheets, as well as when you have suppliers and purchasing people buying that product. It's important to know that they understand what that product is. Write into purchase orders that this material should not include any of the other hazardous items that you might see that they may deliver. Basically, again, developing the standards to do that is going to help you in the long run from an environmental standpoint and a surface treatment area. The other item, when we look at, when you're doing surface treatment, we have to look at the waste generated from it. So What we like to see is, at least most of the industry, is to separate the alkaline waste and the acidic waste and paint waste, so that way you have a handle on controlling what that water is seeing, and what that the contaminants from that processes are. Typically, paint waste. In the case of electrocoating, you might have paint solids, BODs, which is biological oxygen demand, some solvents and chemical oxygen demand requirements, and paint solids. But typically, that particular type of painting is very environmental friendly. Same thing with powder. So recycle that powder. There's plenty of people out there that'll take the powder that is not used with the powder fines, liquids, the stripping aspects of liquids, and even powder. Those are all aspects of what we have to control. Uh, One of the key elements of racking and material handling through a whole plant is establishing the production needs and identifying the production targets that you have. If you're going to be a captive shop, you identify what you are in terms of what the products are going to be, what you're going to be having to handle, how you're going to handle that from fabrication to painting to assembly or shipping. And one of those areas that our biggest concern is that the control of that production through right now Ethernet and wireless control systems, where you can download serial numbers with RFIDs and smart reader tags to identify from fabrication what that painting needs are. The same goes for the custom coder. When you look at custom coder, they have a bigger challenge. Um, their production varies, customer dependent. But if a customer brings in a product and identifies what those products are, the custom coder has an ease of a system that can be identified what that process is, what is needed, and what his responsibility is to deliver a product to the end user for paint performance. They have to adapt to the variety of parts needs, and that's what a custom coder's specialty should be. The variety of processes adapting to each customer needs is important. So they may have multiple lines of surface treatment. May have multiple lines of paint finishing. Um, Again, one of the biggest things in racking is itemize all the parts to identify production, establish total parts by process. If you have galvanized, if you have carbon steel, if you have aluminum on one big plant, all three of those are going to be different processes. It may be one paint process like powder or electrocoating or two coat applications, but the pre-treatment and surface treatment is going to be different. The methods of keeping that product to the highest performance level is the key element of surface treatment. And when you look at the aspects of having a chemistry that one fits all, you're sacrificing maybe some of the performance characteristics for maybe galvanized or maybe aluminum versus steel. Or if you're doing an aluminum and galvanized process and you're using, let's say, a cleaner that is not as aggressive for those, and you're putting carbon steel in, then you're ending up having to sacrifice some of the etching area or cleaning capability for the carbon steel parts. The major concern is weld areas and things of this nature. And today, many of the surface treatment, which used to be simple 20, 30 years ago, was just a clean only with high strength alkali cleaning, now is going to milder cleaners, lower temperature cleaners, as well as acid pickling now, whether it be acid pickling or neutral pickling with a high pH to etch those areas for both safe for aluminum and galvanized, whereas acid pickling is used to clean up the welds, and oxides for the surface impediments for carbon steel. Determine that coated surface area and weight. When we look at the needs for racking, you have to understand what is the coated surface area and weight to identify the objectives that you need to get the amount of coating that you need and the amount of surface chemical that you're going to need to do the treatment. Uh, Develop and establish procedural steps to control the parts painted. I mentioned part designs and manufacturing steps, and identify the chemical part contaminants. Identify the part substrate with the paint process, and production part racking. Identify all the sources of the paint costs. One of the things that people don't understand every time I go into a plant is they don't know what their paint cost is. Well, what is it costing you to paint that product? It seems like everybody seems to bury that cost. You're buying, the purchasing guy is buying the paint and chemicals. There's consumables, bag filters, nozzles, replacement parts for the paint line. The other aspect is also, the energy costs, the utilities. What is it going to cost you to run? The gas, the electric. Everybody wants to go to gas get away from fossil fuels, but we've had customers ask us to what the cost is going to convert from gas to electric. Now, when you start looking at going to electric, the cost for electric versus what even the gas cost today, even at a higher price, is still much more economical to do fossil fuels. And maybe in 20 years and 30 years, it might get more economical to do, but to convert that, all the existing plants to electric from gas and fossil fuels is a very investment capital intensive. So, those are kind of things. And the way you can establish this is that you develop your chart system, and I'll show you just briefly here how we can kind of take a look at that, what those costs is going to be. This is where the coated surface area for both whatever product that you're painting, the cost for handling and labor, the cost for utilities, the cost for cleaning and painting, racking, the racking cost, the tooling cost, the rack stripping, the waste treatment, and maintenance costs all get put in to the cost of that product. And if you don't establish that cost, you're not going to know what that true value is when you go to sell that product to a customer. Now, a custom coder knows all those parameters because he deals with it every day. However, you have to look at it from the standpoint of those costs rising. Nobody wants to see an increase in cost. But if your fossil fuels or your chemistry or your paint cost is going up, it's a way, an avenue that when you establish their costs, you can illustrate to your customers why those costs are being implemented. One of the major things that everybody should look at planning-wise is develop a process flow chart. Whether you're a custom coder and the processes that you need, every customer that a custom coder should have should be applied a flow-through process. When he receives the product, from what process those parts are going through. And it gives the customer an identification of what that process is and all those step parameters. So that if you have a reject or a rejection area, you can identify it. The other side of it is that if you're a captive shop, look at it from the standpoint of how many different fabrication cells you're going to have, how that product is brought and delivered to the paint line, how that product is going to go from the paint line to the assembly, and what assembly cells. Every plant that manufactures today should have some kind of a flow diagram chart to understand. And What it gives is that if you illustrate this on bulletin boards for employees or anything, it gives the people that you hire and your employees a method of understanding what goes into a product. So it's really essential to have that communication today, especially with a lot of the labor market that maybe not quite educated enough to understand it. But if you communicate those processes to them and what the functions are from start to finish, it gives them an incentive to understand all those different processes. So, determining the process objectives are essential, and paint performance to identify that process. I think I mentioned the metal preparation needed, whatever paint needs you have. It may be epoxy, acrylic, polyester, and those are determined by a lot of the paint suppliers and chemical suppliers that help aid you. But basically, the customers out there dictate that application. Maybe you have the type of second coat for an application for a two coat application. It might be a spray liquid or a powder. Which is easier? If you have many colors, is powder the right way? Yeah. Well, if we go to spray liquid, can I do water based? Can I do solvent based? How much VOCs are going to be in it? And again, the VOCs and the amount of usage all go into the application of how much surface production you're doing. The utility aspects is how much mass you're going to be utilizing in that paint line. And so it's an important factor of knowing all those criteria going into a process. For those that are running it now, currently running paint shops, get that get some of the engineers or people that are responsible to help you facilitate to get a handle on what those costs are, because today the marketplace is so competitive. You can either lower your price and not know what your costs are and take a bath on it, or know your price and have some leverage with your suppliers and your customers. So some of the objectives that are, especially for captive shops and obviously custom coaters, if you could get parts that are pre-racked, that's great because that saves labor. You develop racks for shipping. Minimize the double handling. Can the parts? One of the ideas for captive shop is can the parts be racked at fabrication? Some of the techniques could be manually or robotically. A lot of the trend today, especially with the tier one and tier two suppliers, are using robotic loading capabilities. That dictates the type of rack that you have, because your densities might, if it's a robot, your densities might not be as high as a operator can load, in tight spaces. But the robotics and the programming for robotics are getting better and better to facilitate high density loading. And once you handle that, you just take that rack over. It's simple to handle a rack that's over. And I'll show you some of the techniques that we can do here to facilitate. Here you see on the right-hand side is a pre-racked part with aluminum products on a cart. They just deliver that, and that cart is then, the rack is then transferred directly off the cart onto a paint process. Can painting parts be unloaded at assembly? So it would be the same thing. If you have a rack that can be moved and delivered at assembly, yeah, it might take a little more space, but you're saving that labor from having someone put those parts in a bin or in a box. If it's going to shipping, it's easy, but if it's got to be assembled, it has to be delivered to that site. And the more efficient you become and less handling, the better, the lower the cost. Match the paint process system with the production requirements. There's a lot of people that buy huge monorail systems that are monsters, that are too big for what their production is. You got to know what your future production is going to be. Projection. Most of the customers out there I see, and I help a lot of the customers do racking and using matrices, and I'll illustrate that in a minute here. to understand what their future production is going to be in 5 years or even 10 years. So we project those volumes out. And so when we look at part rack development, those are the production aspects of different types of parts and how many you can get in there, and they're all different kinds of configuration of racking. One of the key elements to know is the largest part that you're going to have to produce in the paint line, and prepare a paint rack study. And the list should be what your parts per year are. It's very parts per year, day, shift, and hour. It's vital to understand what those volumes are. Whether you're going to run one shift, two shifts, three shifts, and what the impact is on the utility costs and consumable costs to run that. Physical dimensions of the part is hung on the rack is very vital because you know the size of the rack. The part surface area to be coated is, again, I can't stress that enough. It's extremely important to know the coated surface area or the treated surface area. If you're just treating the parts for just cleaning or phosphating only and putting in what do they call it? A part that you want to that aren't painted, rust preventative. I'm sorry, that's what I was looking for. My apologies. You just need to know what that chemistry is going to be based on the surface area that you're going to have. And part weight is all going into the massa. This is a typical rack study. It's called a virtual rack study through an Excel program. The identification of products, it could be, I've gone as much as 150. But each one, you identify the process, what the program is. This is like for a tier 1 supplier or tier 2 supplier, the annual parts, the area, surface, and this all goes into negotiation with your paint suppliers and chemical suppliers, knowing how much surface area is going to be coated is going to tell those customers or those suppliers of yours to understand that you're doing a lot of volume here, and the cost of the paint, if you're going to go 1 mil or 2 mils on a powder or electric coat or whatever it may be, it all goes subject into how much cost you're going to be paying. And then basically knowing the breakdown of how that is per shift, annual treated surface, the coated surface per hour, the parts per rack. How do you establish the parts per rack is a means of basically taking the Excel spreadsheet, putting in the physical dimensions of the product, how you want to hang, and putting part clearance, whether it be 5 millimeters spacing in between each part, 10 millimeters. This all can be done on a matrix. And I've done numerous studies over the last 20 years here with customers needing it. What's unique is it's good for the custom coder because he needs to know, but it's also good for the captive shop because if they decide in a new program, they're going to either buy a machine or they're going to go outsource it to a custom coder. They'll know what that cost is and what that capital investment is going to be from an investment capital as well as payback 1 or 2 years or whatever it may be with all the utilities. As you see on the one right hand here, there's cost per part and the cost per rack. Basically, that's derived from a linked Excel sheet that you enter. Each customer enters their utility costs, how much you're paying for component parts like bag filters, spray nozzles, and this is all part of a summary that tells accounting and everybody else what you're paying, and you can see current developments of how that part that cost either goes up or down. Obviously, you have to do, after the virtual study, you have a little rack study. It's important to get the outline of the largest part. You do your part study. This happens to be an immersion process study for component parts that'll be electrocoated. Um, with the overhead continuous systems, monorail rack studies for spray and immersion. Uh, 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 if you're doing a spray application, don't be fooled by trying to load too many wide end parts, because if you're trying to spray those parts in a combination of immersion, it, those parts will not see the sprays because they'll be robbed. They only see a line of sight, and you may not get all the surface areas. And that's pretty well known in the industry, but a lot of people still try to do it. And it's a matter of a spray application is contact time. So if you're doing a cleaning, it's always, if you've got a product that's relatively simple to clean, it's easy and flat. But if you have geometries that are box shapes or other types of hidden areas, you may not be able to do that. It may be a requirement for a combination of immersion and spray. What it does do is, it minimizes the amount of chemical draw and drag out when you use a combination of both. There's obviously other ways to group parts with a power and free conveyor, utilizing banking. One of the big facility advantages to going power and free is it's a flexible way of loading for high dense racks, as well as splitting them for application for spray coating. There's different specialty racks. When you have heavy skid racks that we call skid racks that can be delivered to a different technique in terms of handling instead of overhead. You may have to have for electrocoating. You may have areas that are recessed inside. You put auxiliary electrodes in there with a conductive bus bar. You end up having the ability to get uniform coating. They're self-tilting racks, parts that having deep cavities allowing the air pockets. These are sail racks if they go into immersion or even immersion chemicals. There's numerous ways of tilting these racks and how the flexibility can be done through using cone shapes and sail, what we call sail flags that allow the rack to burp those loads as it's going through an immersion process. There's different types of racks that are going, the specialty racks for bulk coating. If you're not bulk coating and you have the capability of doing that, I would suggest that consider it. Here you see springs. There's touch marks with electrocoating. Obviously, with powder you can't do this, but for electrocoating, you can actually do a bulk, and this is several people are doing this in the marketplace. And if that spring has a color code that has to be applied, that is then taken and hung on a load individually for powder coating. Again, customers, if touch mark, typically touch marks are, with electrocoating, they still have the performance requirements that you can get because some of the touch marks are still less prone to corrosion. So one of the things that have been used in the marketplace is basket coating. The fastener market is very big in construction fasteners and even in some of the automotive fasteners where you use barrel coating. One of the barrel coating allows you to minimize the touch marks by shifting it during the processes during electrocoating. So, for example, when you dip this barrel into electrocoat, you can orientate the parts after a minute and shift those parts a little bit to allow more deposition on the touch mark areas. So this is very successful in the marketplace today. Some of the terminology that maybe some of you don't know is we call this rack load densities. And in electrocoat product rack development, just so everybody understands what it is, it's always also important for liquid and powder, is the ratio of the part surface in square feet compared to the cubic feet of rack volume. Typical E-coat rack load densities for anodic and cathodic epoxies are 3.5 to 5 square feet per cubic foot. That's the load densities that we see. Now, we that's the average, but we've seen, as I mentioned, I just go back, you look at these load densities, you're looking at roughly 10 square feet per cubic foot of rack volume. And the same goes for a barrel. There are special needs for that using, in the case of electrocoating, conventional steel analyte cells aren't used. It's precious metal type electrodes are used because of the amp densities. But being able to coat that ability through deep recesses is very successful in today's market. In anodics, with acrylics, they have less throw power capability, so your densities are going to be a lot less. With epoxies, they have higher throw power. Parts can usually be hung in a rack in multiple widths, optimizing all kinds of load densities. Rack stripping is minimized with thin film pre-coating of racks and baking those racks, and I'll go into that. Some people don't understand that, but if you get a new rack or have a rack stripped, if you thin coat to about 2 to 3 microns, or 0.1 to 0.2 mils, and you use hardened steel racks, tips, you can break that surface and maintain ground for electrocoating. Some of the rack load densities that you see for liquid and powder, these applications are smaller load densities. Rack spacing and line speed determines the density, more so than the number of parts per rack, only because they could only be hung single hung. The tighter the rack spacing, the higher the density, obviously. But it also depends on the gun technology you're using and the ability to coat that kind of density for the guns to keep up. Typically, the rack spacing and density depend on, like I say, the guns used. Your densities are a lot less, obviously, because you have to coat. But there are techniques that you can improve on depending on the type of pretreatment process, surface treatment, and how we want to approach the application of top coat or single coat systems. Again, for spray coverage, it's important that the densities can be kept up through rack spacing. You can maximize the amount of parts on a rack just by having basically a complete sheet wall of even if it's small parts. If it's if you have a full sheet of sheet metal that you're applying the coating, it's the most efficient. You can control the film build much more closely. But when you have small parts spaced widely, it's very difficult because you get a lot of wrap and you're trying to compensate for any Faraday cage effects. The rate of rack wear and replacement is higher than electrocoating, just so you're aware. So, electrocoating is great if you have up to 50% one color on a paint line. If you're doing 100% of one color, it's a single coat like red, black, green, whatever it may be. That's the most efficient, and you want high film builds. Some of the high film on electrocoat, you can get up to almost 1.5 to 2 mils now. In powder, you can get multiple colors and multiple thicknesses. In the case of color coding for electrocoating, you can establish, if you have 50%, that's where your justification comes in. If you're doing multiple colors and you're saying that maybe I have 40% of one color and you have 40% of another and the rest is 20%, you can probably design the line with skipping those electrocoat areas and applying just a powder top coat, single coat. So there's numerous ways of approaching it. Here's the kind of rack densities that you see. On the right-hand side is a single one coat for the outdoor garden market. Those are actually engine covers. They're laminated. So it's a process that basically for sound deadening, and basically they do a two-color application. They have 50-50 split. Here you see high rack densities for products that are loaded going into the electrocoating. And of course, different rack styles that you could apply, different racks for a load bar that goes through pre-treatment immersion process and electrocoating. That's a typical type of rack density. If you're not going to those densities, see these racks here, if you look at them, they actually are going to be, some of those racks are going to be offloaded and powder coated too. So you can see why the style of rack is chosen here. One of the things that I want to educate, if you're not electrocoating, you don't know much about electrocoating, basically it's a process where you have paint solids and you're basically applying a charge to the paint solids, and the paint solids migrate to the surfaces areas. One of the unique things that you have is the current density and the flow of voltage goes across these, and the solids that are hit the surface around the area bombard subsequent solids, bombard it and dehydrate that coating, first layer of coating. And that's through the electroosmosis, which is basically the power generated from the current through. One of the problems, and a lot of the people make mistakes, is that here's a rack that's going to go through. When you see this type of, here you see the same product, the electrodes are always located on the sides of the tanks. And if you process through a square transfer type system, you want the current to flow through these parts so that you get a lot of solids and a lot of current flowing through. If you load this way, you're blinding off the center ones, and the current has a hard time getting in. What happens is you get inconsistent uniformity on the paint coating. Here you have a diagram that I'll show you just to give an idea of a product that is used here today in the EV market. There was a customer that loaded his racks this way, and the direction of travel is going this way, which is this way in the plan. The electrode, he had to put additional electrodes here, but initially they put electrodes on this side and on this side. And what happened is the current, those little arrows that you see, had to follow through and have a lot of resistance. So basically, they ended up having overcoat here of higher film build than the ones here to achieve the minimum thickness. When you load a product in a orientation that basically is such that you allow the current to flow through, the distance here is 2 feet longer than the distance here. There's less resistance. So, and the paint solids either way are going to go through it, but there's abrupt changes in it because you basically want a circulation of motion there. But the current is the most important to get the uniformity. So just a little education on that end of it. And it actually goes for powder too, because it's electrostatically charged. But basically with a single, there are products that can throw, depending on the spacing with powder, you can space these larger, and if it's a short distance, you can corona charge that and still get the powder applied very well. Typical spray liquid powder densities just show you. Here you see a cart. Now this is a captive shop. They do light poles, 30-foot light poles, but they have small parts. But you can see that you can get, and here they're doing exterior work. So basically, these parts will be electrocoated in a two-coat application and applied for coat. But you see that you can utilize this rack for powder coating in a load bar situation. And the parts are actually run through a immersion process, and then it goes separates through to a powder. And again, you can see some of the densities are there because, again, the more product that you can get closer, as long as you can reach those powder areas, in this configuration, the corona charge is going to hit it very well. The one on the right here is simplified, where you have one-sided, and you can do two parts per rack, double stacked, which gives them a single coat on one side. Same goes for this particular product. So you can see that the densities are that, and then when you look at liquid, sometimes it's even worse. And here, your densities are not as high. If you're using conventional air with a liquid system, or HVLP, you're going to get some wrap, but if you got to coat both sides, you're going to have a double rack, double load booth, spray booth, and your rack densities, the spacing's got to be a little bit higher or larger in between. Typical rack densities for two coat, as you see here, you see the parts. These are for luggage racks. Basically, it's an inverted conveyor to basically get the E-coat coming through, and you have as much density as you can. Why can't we coat these twice? Well, basically, a luggage rack has to be coated on both sides because it's going to see exterior ultraviolet rays on one side and moisture on the other. So they powder coat these and apply. But a typical rack can be hung with a lot more density. But in the case of two coat applications, you are going to lose a little bit of rack density because of the powder coating application. There's two ways of thinking on two coat system application for rack processing. Design the system with two separate lines running, where you have a dedicated prime and E-coat top line. The positives on that is a higher rack density through E-coat, which is great. You can separate those. Multiple part racks can be run in groups, and individual racks transferred to top coating. The negatives are racks must be transferred to the top coat line. The higher labor cost is going to be due to the rack transfer, obviously. There's going to be more racks and more complex configurations for that. Here you see a plan view of the system where you're using a square transfer device, which is optimum efficiency for pre-treating and coating for two-coat application, and then transferring. These are for shopping carts, by the way. The parts have to be transferred to the line. There are other advantages to doing it, other techniques. If we look at integrating the two-coat paint system rack processing, we could do what we call load bunching. You design the system using a conveyor that load bunches through prime electrocoat and splits the loads through top coat. The positive is higher rack density through E-coat. Multiple racks can be run in groups, then split individually for top coating. The negatives are paint system conveyor is a little more complex, and there are more racks in the system. Here you see loading and unloading taking place. They have wide loads or narrow loads. And what they do is they process these racks. It's split through. If it's a wide rack, an empty carrier goes through. If it's a wide rack, if it's two narrow racks, it goes through the process, comes back through the oven above, and then is transferred. The E-coat parts get unloaded here only. The powder parts get through and cued through powder and applied through electrocoat powder baking. So it's a simplified version of this, in terms of using power and free. You could use a monorail that could go through and take off those parts. there's a lot of different ways. A monorail density, remember, if you load to a monorail, you're only single hanging it, because if you go to a spray dip, if it's an immersion process is one thing. If it's all immersion, that's a long system compared to a square transfer. If it's a spray and a combination immersion, you're going to lose some rack density by doing that. So remember, with immersion monorails, you're going to have longer immersion times because the inclines and declines. With a square transfer is less tank volume, less chemicals, more effective. The cost per product is going to be less because the energy cost is going to be less than a monorail, and you're going to have a lot, for the applied amount of parts that you have on there, it's going to be such that you may end up seeing a lot more cost in a monorail versus a square transfer type system. But that's another subject. Here, I was going to explain to you how that works. Is with a powered free, you can actually take and have a wide load, but to get the efficiency of narrow loads, we can design the line so that your racks can be done 3 at a time or 2 at a time if you have a medium part. So it gives you the flexibility of what we call rack bunching to make it more cost effective, the price per rack, the price per part. And here you see some other configurations about that with liquid as well as e-coat and powder. Today you would see quick color change. There's a lot of people that still use cartridge booze, but here you have the phosphate system, the primer, e-coat baking comes out with 3, and then you would either go to different types of booze for liquid, and then go to what we call a square transfer type bake oven, where you have an overhead bake oven and a cooling tunnel underneath, and then it goes out, or eco parts go directly out. In this case here is the same, where you have the application of dedicated e-coat and powder. Minimizing part handling considerations. Develop and transport a system to pre-rack parts remotely from the paint system. As I mentioned earlier, utilize the same people racking at fabrication or robot loading or at weld assembly operations. Outsourced parts suppliers should consider pre-rack parts. It's going to save you money if you go outsource, and the custom coder would like to have self-supporting racks. In the long run, the tooling costs that you pay the custom coder to is going to give you that ability to take that rack, load it at fabrication, ship it out, and say, hey, we gave you a rack of parts. If there's parts missing, hey, we gave you a full load, and then bringing those parts in for assembly is going to save you a lot of handling and scheduling issues. Dedicate a team responsible for loading and unloading. Create incentive as to, those teams of people, if they're at fabricating, if they're a captive shop, make sure that you have one guy responsible for making sure that the fabricators are loading it, fab cells are loading it the way it is. And that's self-prepared. I mean, if you have a robot, they already know. If it's an operator, they probably already know. But, you want to be able to fill those racks up. A lot of people have, it's a half rack. We need those parts. Go. It's going to cost you more for those parts with a half rack than it is a full rack. Eliminate double handling, as I mentioned, and implement programs to providing a flow-through process. I think I mentioned that to you earlier. Definitely different types of conveyor systems to do such things. There's obviously a monorail continuous moving, power and free, which is the applications of continuous or intermittent cycling of racks and load bar systems, and indexing systems, which is intermittent cycling. In a continuous moving system, to make it most efficient, it requires dedicated part loading and unloading manual operators or robots. So what you see here on the left is basically a very long, continuous moving conveyor, and you have to have multiple locations, plus you have to have staging areas for parts that you're delivering to. Now, if you have a rack cart system and those rack transfer, having the ability of those racks to be light enough to transfer onto those trolleys and conveyors with overhead, that simplifies the system. But you still have multiple operators, and yeah, you're not spending the time of those operators loading, a lot of small parts if they can be done at fabrication. Rack densities can be improved on racks depending on the spacing. One of the things that you run into is that the inclines and declines in a monorail system often require large spacing in between, for rack spacing in between. So by implementing different attachments called an angle pivot, a guy by the name of Jim Dooley had developed this. You could actually get a little bit, almost up to 50% more utilization on rack spacing than a conventional monorail overhead system for inclines. Because what it does is it turns that rack as it goes into the incline through gravity at a 70-degree location, so that way you can fit racks tighter in between. But again, the conveyor can be routed through the plant areas, but you got a physical, you have a monument that you're bringing those racks to the fab areas and assembly areas, and that takes a lot more capital cost. There's other methods of loading in a type of square transfer, or even other methods. As I showed you here, we have cart systems that can be done on a power and free or even a square transfer. You can have these racks preloaded and then have a manipulator where an operator just loads it right on. You have cart systems that we can automatically transfer onto a power and free carrier or a indexing monorail. The same with a pallet truck, where it's a self-supporting cart system or even a self-supporting rack. Here you see one of the biggest trends in robotic loading is that we develop a rack prototype for the client that robotically loads this frame. The frame has a certain support structure. This is kind of showing a bare frame, but there's a lot of little attachments that go on it. What it is that this frame then is located by the weld cell or fabricating cell. Robots or an operator loads it. It could be delivered by an AGV or a forklift driver with an accumulating roller conveyor that allows a chain conveyor that allows accumulation of 30 minutes or 40 minutes, depending on the lunch break. And it continuously can feed a square transfer system through the process, unload it automatically, and accumulate those for the AGV or a forklift to pick it up. Here you see a typical style of that, but it's very big now in the automotive areas because more investment capital is being implemented to minimize the amount of labor costs. So the configuration of the racks that you see here, going in, coming out, and going out for either forklift pickup or an AGV. And here you see them accumulating. Another method is the power and free, where you have stationary areas where you can actually load free rails or remote areas. This is good for captive shops or not captive shops that are custom coders. They can have different cells for loading the highest rate. Remember, a custom coder wants to load that rack up as much as he can. And here you see that even in E-code, they can do the rack bunching across there. And of course, these can also be done with powered rail sections or free rail sections, but you have a support system accordingly. So, when you look at the back side of this is not such a bad way to go with self-supporting racks. And we designed the system so that we minimize the amount of drag out through the chemical stages and paint stages. And if these need to be done through powder, we can then have the robots unload those and transfer it directly to the powder coating. But in a single coat for corrosion resistance, most customers and most plants, do one coat applications. Some of the part rack design features that I'd like to talk about that people miss are the actual construction of the racks. Um, one Everybody I see has round uh, steel racks, and what they don't understand is that it's so hard to retain grounding. If you're using conventional spray guns, it's no problem because conventional don't have electrostatic attraction. But if you're using electrostatic powder or electrostatic liquid or even e-coat, you really need to make that surface break every time you put a part on it. Uh, so what we're looking at here is fabricate the racks with square and rectangular steel members. The edges make good contact for grounds. Serrated case hardened points are very good for maintaining ground. Even if you have up to half a mil, those serrated edges will break. It will break that surface, and by having them hardened, is not going to be wearing so much. New racks should be pre-coated if they're, to thin insulated film. Now that's great for e-coating, right? What about powder? Everybody wants to go powder. Think about it. How much powder gets applied to a traction of a rack that has just been freshly stripped? Now, one of the things that you could do is you can actually pre-coat those through electrocoat or a supplier with electrocoat, or you pre-coat that with a very thin powder and bake those racks out, and having that edge with a square edge, having that area with a grounding gives you the ability to retain that ground in a very thin coat, and minimizes the amount of powder being applied on the rack, because what you end up with is an insulating quality. What is the physics of electrostatically applied corona charge? Is it goes to ground. Conductive electricity goes to the first closest ground, and that's where you're going to have. So what I'm trying to say is, if you have bare steel parts, if you can pre-coat those racks, is great, because it's going to save you on rack stripping. Minimize the rack stripping if you can. Rack designs allow smooth surface drainage. Having the smoother finishes in a lot of areas going to minimize the amount of carryover from pre-treatment. Multiple rinsing for e-coat is ideal. Here, basically we design racks so that one of the things called the universal rack. You may have a large rack, but the components that need to be stripped, using square shapes, you could use a universal rack by just implementing small universal racks, which have small hook plates that allow you to rack in multiple rows, and in as well as multiple heights, multiple single level, and by having those individual racks built that way, you can then take these small areas and have them stripped. You're not paying a huge volume of racks. Sure, you're going to have the conductive frame get powder coated, but if you have that frame already electrocoated or powder coated, insulated, the areas that you're having blind for grounding are going to be hidden around an area that is surrounded, where the bar is going to be grounded. This bar will be grounded through the hook area and will allow you to retain the ground. Here you see one of the things that rack design considerations that I have to share. These are great. Small parts racks are really great. Spring steel hooks and clips are great for small parts. They are terrific. There's some good positives. It holds light parts on a rack with force, easy to put on and take off. a rack frame, easy to strip with a chemical if you just, and again, you're not going to sit there and burn these off. You got to throw it either in a chemical or a hot sand. And there's multiple configurations. They're great. The negatives to that is the risk of falling in immersion processes. Even though they say they claim, some of these parts may act as sails depending on the configuration. No matter what force you have, if you're moving on a continuous conveyor, um, you're going to have forces against that, and it can pull that spring off real easy. The rack frames can build up paint and to prevent grounding. If you look at these configurations, they're terrific for holes and stuff. But if you're applying, a coating on there, it's going to see it. You're going to have to strip that frame more often, and so there's a limited lifespan on the springs, and the frames would have to be, stripped. And burning off these lighter weight frames are probably not conducive because of the thermal shock that it goes through in the high temperature. Of course, there's controlled pyrolysis burn offs that control a little bit more of those rack temperatures. But the longevity of those frames aren't going to last as long as a heavier fabricated one. A few rack maintenance tips that I wanted to talk about is try to utilize the same universal rack components for part support members, allowing interchangeability. This is really the key element in having the parts, knowing that the racks can be the same and stripping can be the same. Racks with case-hardened contacts last longer and provide a hard ground surface. The electrocoat racks maintain minimum post-rinse solids. What we're trying to do is, if you can just, with electrocoating, the key element in cleaning up those racks after e-coat, because remember, in e-coat, when you thin coat a rack, that e-coat is not going to apply another coating on it. It's self-limiting. But if you have solids that are dragging into the subsequent post-rinses, you're going to have, and they stick to that rack, they're going to be baked on, and then therefore stripping. Now, there's most of the rack stripping and electrocoat is probably twice a year. And normal customers most of our customers are once a year. They just want to make sure they're cleaned up. But the key element is to get rid of those excess solids, to have more permeate production and considerable more rinsing. The conventional is 3 post rinses. By going to a 4th post rinse gives you the ability of paint savings as well as cleaning savings on the rack. And then of course pre-coat these racks, as mentioned, for insulating them. In the case of electrostatic spray, liquid, and powder, utilize the same components as the racks, as I mentioned, interchangeability. Case harden those contact points. If possible, load parts on the rack to try and blind off the ground areas. There's many areas where you may not necessarily have, the customer that you're supplying or your product can handle a little touch mark. If you can blind off that area where powder doesn't need to get into, that saves you a lot in terms of paint stripping. Again, in terms of chemistry for pretreatment, multiple rinsing is important to keep the chemistry from going from stage to stage. Pre-coat and bake the racks to insulate it, enabling good ground at contact points. Now, one of the things that you have to understand about powder and even liquid, it's against the NFPA to go beyond 1 megohm resistance. Many custom coaters and a lot of guys that I see, those racks build up so much resistance that you can then cause a fire in the powder or spray booth. It's important that those racks get stripped. So how do you alleviate and improve that between stripping. Install a grounding bar. And again, having a good grounding points is a key element. But a grounding bar to ensure the racks make contact. This is above the powder coating application. If you insulate those and have just the tips of those racks, have those ground areas, being able to have that part hit that, uh, you can then make sure that the continuity is going to be important to have the least amount of resistance. And having a grounding bar is important. Grounding bar has to be grounded with a bar that goes to earth and is wired to that area, and allowing that hanger at the top part of the conveyor, overhead conveyor, where you're actually conducting that bar, that rack, which is bare, not doesn't get powder coated, to make that contact, so that that ground is always there through the insulated rack and through the tip of that particular point of contact with the part. Rack stripping to retain life and retain these rack shapes. These are one of my favorites, but you may not like it. But shot blasting is probably the easiest to retain it, and chemical stripping is, and hot sand. Shot blasting, it requires either an automatic or manual. Automatic is very difficult because of some of the surfaces that you got to hit, but manual blasting is really one of the best ways to retain the rack, because the more you burn off a rack, the lifespan. If you rack burn off, it seems easy, but it reduces the rack shape and the lifespan of that rack. Hot sand stripping is great, but it's investment costs. You got more utility costs. We see chemical stripping as probably either inline or offline, with high caustic strippers, and some of the new materials that are out there, safe for environmental, is very good, and we see more and more of that. In summary, I just want to just say everyone wants a good paint job for a low price, right? Well, what does it take to get what we need? Points to remember: eliminate production need, establish production needs, identify paint objectives, eliminate or minimize double handling. Remember, these are the points. One of the other things is know your total paint costs. Remember, I showed you that spreadsheet, and I'd be happy to help facilitate you on how to develop one. Plan on good rack development that minimizes tool costs, the best fit rack handling methods in terms of material handling for part loading, unloading, and material handling for your needs. And tooling cost depends on the maintenance. That the more preventive that is done, the lower the cost. And with that, I'd like to take any questions that you might have.
Actually, Ted, I believe we've run out of time.
Oh, I'm sorry. If there's questions, why don't you email me?
Yeah. So we will also have make sure that Ted has all the questions that have come in, so that he can reach out to you offline. And the contact information is right there as well. There's also a handout in case you missed anything in the slides. You can download the handout as we kind of wrap up here. And if you do need that, you can just ask for it as well.
Yeah.
I'd like to thank Ted so much for this great talk. And thanks so much to our attendees for taking the time to join us today as well. We really appreciate you being here, and I hope you'll join us again for the next Products Finishing webinar. For
Thank
more
you.
information, sorry, Ted.
Thank you for allowing me to present this. I hope that people out there could understand what my points were, and sorry for taking up a little more time than I thought. And everybody who needs the applications, please give me a call. Don't hesitate.
And for more information on our webinars, visit pfonline.com/webinars. Thanks so much, Ted, and
Thank
have a
you.
great day, everyone.
Thank you.